Is it live now? Let me check. Okay. Okay, it's live. Okay, let's start now. Let me check it out. Okay, it's working. Let's start now then. So, the topic we're going to understand today is how does DNS work? What does DNS actually do on the internet? And why does DNS even exist in the first place? As internet is a very complicated infrastructure that we're able to access all kind of information in the internet, so there must be something that handling all of this structures and servers so that every user that is trying to reach a website, a server or anything, it can reach the right destination without visiting somewhere which is malicious, visiting website which are very scammy, spammy. So DNS does the work related to that. So first of all, why does DNS even exist in the first place? So every server on the internet has a numeric address, which we call an IP address, something like 2 to 50 and 6. This is an IP address, the numerical address of every machine that is on the internet. I mean, not exactly this, but it looks like this, as machines only understand the numerical values. So every machine has this address. For example, a physical address like every house has, there is also an address, numerical address for every website that is present on the internet. So as your browser can't actually do anything with when you try to visit google.com directly, it doesn't know how to reach google.com, as google.com must be hosted somewhere on a machine, and the machine only speaks in numbers. So before a single byte of data can move anywhere from your computer or from the server that is hosting the Google, the human readable name that is google.com is translated, or in technical terms, resolved from this to this, and it has to happen under 100 millisecond, invisibly billions of times a day, across planets worth of infrastructure. And you probably also heard of the analogy of phone book that DNS is, that DNS means that phone book of the internet. But is it also true? I mean, it's a good starting point, analogy starting point, but it collapses quickly. For example, the phone book is static and it is one copy, lookup takes second, time consuming, and there is also no caching. This is what a phone book is actually. When you have to look at an address or a number on the phone book, you have to search through thousands of, millions of names manually. But DNS is very sophisticated distributed system, as it's also constantly changing. This is the address of a machine. It changes according to where you are, what network you're using, what resolver you're using. So it kind of keeps on changing, and it is also global. It is not present in one specific place. I think it's around 13 plus places that the infrastructure is placed, that handles thousands, that further is divided into thousands of servers, but there are 13 main servers, and the lookup takes millisecond, and there is also caching. That is the main cached. That is the main part that makes the DNS what it is. So now that we have understood what DNS actually is in an overview, let's understand why you actually need. Why do you actually need? Okay, uh, let's glance over DNS one more time. So DNS is a system, a distributed system that helps you to resolve this alphabetical address into this kind of address so that you can reach the right machine. So how it will find the address, this numeric address, is what is the main content of this video. The main system that we will talk about, how your browser, how the elements that are in the browser, for example, the resolver that uses the URL to find this information. We will talk about that. So first of all, why do we need to understand DNS in this AI era, even if we have so many agents running around doing everything that an engineer, software engineer can do? Because when DNS breaks, it breaks everything, your app, your deployment, and your users access, and the users that are currently visiting your website, it will also break that, all of it. And the error messages are very random, and it's not exactly helpful in a manner, and you also will almost never get a error that will help you resolve very quickly. For example, if there is a DNS related error, you won't get a message like on an error message like your CNAME is misconfigured, that you're missing this. You will get a timeout error or a 502 error, or your page would just don't load at all for users, for sometimes all users, but usually it's some part of the users that are not able to access the website. So that then at that moment will your understanding of the DNS will come in handy, as you will be able to, I think, debug silent feature, silent failures, and you can also configure some of the deployment configurations, and you can also alter the performance of the system or application by tweaking the DNS, and most importantly CDN and load balancers. That is the most important part that you will see the effect in when you are probably very fluent in understanding the DNS related errors, or maybe system are trying to debug what does it mean. When I'm talking about errors, what I mean is sometimes your app will work, your app will work fine, and suddenly some users will not be able to access your website. The domain will not resolve, it will show some kind of a not found error, or the users will be able to visit your website, but the new content will not be able to show, as the user will be visiting your old domain, or if you have changed a domain, your user will not be able to visit your new domain. These are the kind of errors that you will most probably come across. And to fix that, you need to know the configuration of the DNS. How does DNS, what are the elements of the DNS that constitutes a perfect working system? And to know that, you have to understand how does the DNS works. What are the elements that makes it such a powerful distributed systems? And when you understand those things, you will be able to alter and improve the performance of your application and improve these security. For example, preventing subdomain takeovers and DNS attacks, you can prevent those easily, and also improve the content delivery systems that are there in the system. So first of all, we need to understand what a URL is, which starts this whole process of finding the right domain. Finding the right domain means that, okay, let's start again. I forgot about a little bit. So first of all, we need to understand the anatomy of the URL and why it is that way. So there is a domain www.xman.com. This is the normal domain. This is the .com. It can be .net, .edu, .in, .os. It can be anything. And this .com is called top level domain. It can be, I think it has many types around. Even it can be, sorry, it can also be an AI .ai domain, but this part is the second level domain, what you register with the authoritative domain name that you will have. For example, this can be Instagram, it can be anything, tab. So this is the second level domain. But how does the DNS start? First of all, when you type this www.xman.com in the input URL input field and hit enter, this is not the same URL that the DNS sees. It sees this www.xman.com and then again a dot. That is an invisible dot, but a real dot that the browsers don't show actually. Only the DNS resolvers that will actually help you reach the address. For example, it has an address of this. You're trying to reach this address using this name. As you know, I told earlier that names are easy to remember, but when you have so many domains, you don't want to remember these things. So it is advisable, or it is built in a way that these names get resolved into these real addresses. So most people read it from left to right, but DNS authority, which is going to help you to find this machine address, it reads from right to left, and that matters because the resolution process mirrors this exactly. It's not a convention. It is because it is built to read it that way so that it can easily found and efficiently found the address. So this is www. It's called subdomain. You know, it's just a convention, and it has no special technical meaning. It can be .api staging. So it's not very important here. Important is .com and the dot. So this is called top level domain. It is managed by the ICANN, and these manage these servers. So first of all, let's go through the working. So when you type a URL, this DNS resolver, that is also called recursive resolver, it will go on the internet using this dot. First of all, it will identify that, okay, this is the real domain, so let's get that out of the way, and then it will read the second part, so the domain, that is called URL, that is called .com. Then it will go on the internet to those machines, that are 13 machines, and that will ask where are the .com domains. So it can filter out .net domains, .edu domains, and all those other domains, other top level domains that are not .com. So it has excluded millions of other domains and is only dealing with the .com domains. And then wait a minute. So where will we? Oh yeah, the recursive resolver that you are using will first of all filter out all the other top level domains that are .net, .edu, .government, so that it can lock in on that certain niche names, niche .com domains, not niche, mixing a lot of things. And then when it will reach the machine, for example, there are 13 or 1,000 machines that are handling all the domains, and after filtering out all the other domains and only dealing with .com domains, it has left with 10 machines or even one machine. And then in that machine, it will try to find the xman.com, and This is the name that you register on the internet, and this is found in the authoritative name server. For example, you have bought a domain name from godaddy.com. For example, you have bought from namecheap.com, and then it will have the information related to the Namecheap. So after visiting .com name server, top level domain, it will try to reach this authoritative name server, which has all the data stored related to xmen.com, and then it will guide you to the server name, numerical name, and then it will give you the information related to that. But first, I want to talk about how does this whole journey looks. It does not directly go and look out for the domains. The first thing the browser does is check its own memory. First of all, you're using Chrome, so first it will check its own browser cache, that if you have visited this website or not, if you have visited these website you're trying to search. So the search in URL bar, did you visit this recently? If the cached answer is still fresh and you will never hit the network at all, and as the IP is already stored in the browser cache, so it will give you the cache stored. For example, you're trying to visit youtube.com and it already has stored the IP related to this. Then your browser will not need to go through this whole other journey of searching the numerical address of the machine server related to this. You can just see this, the browser cache which stores the DNS related data if you're visiting this. And the second step is, if your browser has no cache, then your operating system also stores the cache. When the DNS did not exist perfectly, your browser takes over, your OS takes over. And here's something most people don't know, it is hard-coded in your browser's system files. And if you're on Mac, it is under etc host, and if you're using Windows, it is under Windows System 32 and drivers. And the file is hard-coded name to IP mapping. The files are hard-coded, predates DNS entirely. It's how DNS used to work before DNS even existed. Developers still use it in case have any emergencies, and also helps you to work locally. For example, 127. It will map to my app.local, so that you can start testing locally some applications. And then if neither your browser has the cache, neither your operating system has the cache, then it moves to the recursive resolver. The OS then moves the query that you're trying to reach this website to a recursive resolver. There are, I think, 3 or 4 kind of recursive resolvers. The first one is Cloudflare, which follows this address IP, and the Google has 888. But usually the Cloudflare is used, and your ISP, internet service provider, may also be using its own. But that's not safe. It sometimes steals your query data, so it's advisable to use the Cloudflare IP. And the resolver that we will use after the browser or even the OS does not have any cache stored to the address you're trying to reach. And this is shared across thousands of users. So if any user is trying to reach YouTube before you, 3 or 4 minutes before you, then it will also cache that query on a local system, and it will give you that answer to you if it is within the time limit that is cached stored. And you can change these at multiple levels. You can change the recursive resolver, even your device on a router level, app level. You can change it if you want to change from Google to Cloudflare. Wait a minute. So, and the next step is when neither this recursive resolver is cached any data related to the website you're trying to reach, then it goes through then the resolver climbs the cache, uh, the process to find the domain. So first of all, if the resolver hasn't seen this query before, it starts at the top and works it downward. For example, first of all, it will check the resolver root name server through the globally. There are 13 root servers at entities labeled A to M. That sounds dangerously fragile until you learn that each identity is actually a cluster of hundreds of machines globally distributed via Anycast. Over 1,500 physical machines worldwide, this system is engineered to be essentially unbreakable. And the resolver will ask the root who handles .com domains. The root doesn't know where does x.com lives. It just knows who manages .com. It points to the VeriSign. And then this whole process that we talked about, that first of all it will look for the .com related server, that who handles the .com domains. Then it will reach the .com area, .com machines, and then it will ask who handles the youtube.com. For example, you're trying to reach youtube.com. First of all, it has resolved all the top level domain URLs, and then it will try to find the YouTube. And who owns the YouTube domain? Which company did the YouTube or the Google, which of the parent company of the YouTube is has bought the YouTube? That company will have an authoritative domain server, and then the resolver after filtering of the .com domains will ask what IP address does the YouTube has. That will be found on the authoritative name servers that will hold its own file. For example, can we do GoDaddy, Google domains, whatever, namespace. That will actually hold the answer, and when it finds the answer, it will return the IP to the recursive resolver. It will cache it at the local level, and then it will give to the browser cache. It will give that name to the browser, and the browser will also cache that at the local level. Now, let's go through what does DNS records, what does the zone files are, what the elements that are we need to study. When you own a domain name, you can configure these DNS records in a zone file. Think of it as configuration file for your domain, and there are few things that you will manage, not all of it. For example, the a-name, a record, the fundamental one. This is what your websites, your domain's actual IP address is. It is IPv4 address. When you have a server with fixed IP address, you want your domain to be found there, so this is where it is. It is one-to-one, no third party involved. This is also the correct record. It will not change mostly. And then there is also a record. It is for IPv6. As most servers switch from IPv4 to IPv6, you will see these servers more. For example, these look like this. Yeah, looks too big. Then yeah, that is secure. This is what IPv6 a record looks like. So as more and more internet moves from IPv4 to IPv6, you will keep seeing these more rather than these. Now the main thing is CNAME. It is canonical name. It's called short for CNAME. It maps a domain name to another domain name, not an IP address. For example, you have other third-party services. For example, Shopify.com. You have staging.shopify.com, shopify.buy.com, shopify.brand.com, so that when a browser will resolve these, instead of looking for all these third-party domains, it will try to resolve those third-party domains directly to your core IP address, and it will return that instead of making domain IP address for every third-party services that your brand has. It will resolve that name directly to your IP address. So your main address will, your root address will remain the same, but these will act like secondary addresses so that you can, make other third-party services and without, making more IP addresses. But you can't set these third-party services domain as your root domain name, as there are some restrictions, and there are some, Cloudflare related methods like CNAME flattening. So instead of serving CNAME records directly, the DNS provider resolves the chain internally and returns the record to the client as if it were a direct IP mapping. The interaction is, invisible usually in this. If you ever been confused that why some services works on Cloudflare better than a cheaper registrar, that the CNAME flattening is usually the reason. And the MX record is for mail, is your mail does a reverse DNS search, as when you send a mail, it first reaches you, it checks the DNS, and then again it visits back the domain and check if the domain also have the same IP. So these records are also necessary. The TXT records is the some text files, but it is important to identify the domains ownership verification, Google Search Console related data, third-party services, SSL providers. All these things uses TXT related data. So it's very dense data, but it's not much changed if there are not ownership changes and not much DNS related services are changed. So it is fine. And this is the name server delegation. It is NS is when you register a domain, you tell your registrar which name servers to use. As these name servers are exactly, for example, you may have look at this like NS. This is the name servers that you usually use when you're connecting your website to a new domain. This is what you use. And now let's move to the DTN, time to live. So every website that you visit, every DNS record that you stored has that time to live. It is not cached for a lot of time. It is cached for you can modify the time that the website's data, the DNS, how much time does we need to store it. It controls how every ISP cache and every CDN node will hold your IP address cache data. So usually we use 24 hours. This 86 400 seconds when you are not doing any changes to the website, you're not making any application changes, deployment changes. We usually set this to 24 because we don't want the DNS to look for the IP address every 5 minutes, every 1 minute, or every hour. It will drain our resources. Changes will so why so it will take lower latency. The user will able to reach your website easily when you have 24 hours propagation time. But when you try to migrate your website or your domain data to some new domain, then before you do that, before you change your domain name related data, you can change the TTL 1 or 2 days before that to 60 seconds or maybe 300 seconds, so that every 5 minutes it is caching the new data, and so that you can easily propagate the changes in minutes rather than wait for 24 hours for the changes to take place. And this feels big as when you change the DNS records, there's no way to push that change to every cache in the world. You update the record at your authoritative name server and then wait for each cached copy's TTL to expire. The propagation time is equal to old TTL value, not the new one. If your TTL was 86,400 and you just changed it to 300, the world still has up to 24 hours of the old answer cache. And this is why you can update the DNS records and see the changes on your phone instantly, but not your laptop. Different devices use different resolvers with the different cache states. So the more you save every time, the more you are sticking to this 24-hour propagation. And then the DNS security. There are a lot of things that can go wrong if you're trying to, authentication. As the original DNS protocol had no authentication built in, it was designed in 1983 for a small community of researchers, who used to trust each other, who trusted each other at the time. A resolver receiving a DNS response has no way to verify it actually came from a legitimate authoritative server. It just trusts the answer. The gap is the attack surface. So there are a lot of things that can happen. There is, first one is cache poisoning. For example, here's how it will work. So an attacker sends a forced DNS response to a resolver query. Every to get there before the legitimate response arrives. If they win the race, the resolver caches the fake IP addresses. Every user querying the resolver now gets sent to the attacker server, and the URL in the browser looks completely correct. The domain is right, the DNS succeed, and only the destination is wrong. So to fix that, there are a lot of cryptographic signatures that are applied on the records right now. In the last few years, for example, DNS SCC, this is a fix of that. So, and to avoid the subdomain takeover, we use DNS over HTTPS and DNS over TLS. This is the encryption that is used to avoid this subdomain takeover, so that the attacker cannot directly attack your website